Welcome to Impact Quantum, the podcast where we untangle the quirks, questions, and quantum leaps shaping the future of computing. Today, we're diving into some game-changing news. AWS has unveiled its first quantum computing chip, Ocelot, designed to tackle one of quantum's biggest headaches: error correction. But is this the breakthrough the industry needs? Or just another step in the long, winding road to practical quantum computing? We'll also look at how the quantum race is heating up, with Google, IBM, Microsoft, and even China making bold moves. Plus, we'll ponder the age-old question: why can't we all just get along and build one quantum future together? So, whether you're quantum curious, a seasoned expert, or just here for the cat jokes, let's get entangled in today's episode.
Hello and welcome back to Impact Quantum, the podcast where we explore the emerging field of quantum computing and what that means. And it's not just for technical people, it's also for the quantum curious. And with me today is the normal co-host, that's regular co-host, not normal, that sounds really bad, and the normalized co-host, Andy Leonard. So I think for those that don't, because we really are kind of exploring or expanding our audience here. So in case you don't know what normalized means, it's a term in database architecture. And that was the joke.
I got it.
Andy
I got it too. And I didn't, and I'm not even part of those people, and I got it too. So there you go.
And I think you're right. I think Candace is normal. Compared to me, especially. Yeah, you made the right call.
You're not just normal, you're normalized.
Oh.
So I think we could use this opportunity to kind of talk about, the show and, where we're going with it, but also, elicit, feedback from the audience, but also talk about even AWS is doing made some announcements. I mean, talk to us, Candace. Like, it's been a wild couple of weeks. It's been a wild 2025 in quantum.
Oh, it absolutely is. I mean, Amazon, AWS, they have unveiled their first quantum computing chip named the Ocelot. And it's really to deal with the error correction issues that quantum is having. And it's to enhance the efficiency of the error corrections. And if they can figure this out and solve this problem, this is going to solve a lot of problems for the whole quantum industry. And they're dealing with potentially reducing the number of physical qubits required to create these stable, logical qubits that can then work on the problems. So It's exciting. What do you think?
I can't help but think Ocelot. I think of Minecraft, which is why I changed my background. If you're watching this,
isn't that some small animal?
It's like a cat.
Yeah, it's like
is
a cat.
It?
Mm-hmm.
Oh, okay. Yeah, I don't keep up with my animals anymore.
I have enough animals of my own to deal with, including 3 boys.
Yeah, there you go. And I got 2 teenagers and a cat and three cats and a dog. So I get it. You know what I mean? It's always hectic, but I like it. I like the hectic. So yeah, so it's exciting, right? I mean, IBM has come out and Google has come out, and now we're hearing about AWS, and we've heard about D-Wave in Germany.
Microsoft,
right?
Majorana. It's pronounced Majorana, apparently.
It's pronounced but not Majerna. Like the drug.
No, Majerna is the thing you shoot and then you inject it and you don't stop eating, right? Is that what it is?
Right.
No.
That's it, right? So yeah, I kind of we were talking to somebody on one of our pre-calls, and I had said, maybe naively, why does there have to be one to rule them all? Why can't we have 7, 8, 9 major players? They all get their own qubit to work with. There's enough out there to do it, why can't we just make it like a cooperation of everybody? And then, our friend, said to us, capitalism and all that. But I just think that there is such a wide array of science out there that we should make this more of a massive collaboration of the big brains.
Well, and
Personally.
also too, like it's been decades. I mean, it's been since like the 60s, right? Like now, if you look at home computers, I'll use that as an example. Like it's so consolidated now. There's Lenovo, there's HP, and Acer. But if you're old enough to remember Compaq, Packard Bell, um,
Gateway.
Digital Gateway, that's
Remember
right.
Gateway? Yeah.
Obviously Dell's still around, but like you look at, I mean, the assumption that this is going to be a mature market right away, I think is a faulty assumption, right? You are going to have a lot of players. That's how all industries kind of start up. And I think quantum, ironically, does the kind of the Schrodinger's cat type of thing, right? Where it's both a mature market and an immature market at the same time, right? And what's also interesting, and we've talked with this with the number of pre-calls with guests, and we hinted at this at the last call. Every electronic device you have, from the chips in your car you never see, to the chips in your refrigerator, to your cell phone, to your PC or Mac or whatever smart device you have, they're all using electrons, basically, in these little mouse mazes, right, that bounce around effectively. Somewhere there's a electrical engineer whose ears are bleeding right now, but
well, then come on the show.
Come on the show. Tell me I'm wrong. People tell me I'm wrong all the time, especially my wife.
We love it. We love
it. But that's been settled, right? Electrons to silicon has been pretty much settled since the 60s. Whereas with quantum computing, there's any number of ways to measure a quantum state of a particle, and there's multiple ways and types of particles you can measure, whether it's the Majorana, whether it's photons, ions trapped in some kind of I don't know what they're trapped in, but ion trap, electrons, right? There's all these. I heard of photonic. Photonic is light. Never mind. But there's multiple ways to kind of measure these different quantum states, and there's no one has conquered it yet. Right. And I think in the previous episode, I have a gut feeling that photonics is probably going to win the day, but that's still decades out before that'll happen. And even the guy that we were speaking to, who will be a guest on the show, he's kind of like, well, we'll see. So he didn't dismiss it out of hand, which is good. But in short, Candace, I think you're right. I think there's going to be a lot of collaboration. And there was a lot of collaboration in the early days of computer science. Most of the work was done kind of above board and in research papers, very much the same way that AI is done now, right? So I think that there's room for a lot of innovation here. That's basically what I'm saying.
I agree. So yeah, the news is very exciting. Every single day there's something new coming out. And like, remember I was talking to you about the collaboration between Germany and Singapore. I haven't seen anything additional on it, but I'm particularly fascinated by that because they're talking about quantum communication. And I always feel communication is just the most important thing in life, frankly, like in work and life and in every aspect. So I'm fascinated to know more about that. And I think it's the ion qubits that are the ones that are supposed to be working on potentially like diagnosis, more medical type of applications.
Like quantum sensing kind of falls in that. Yeah.
Yes. And that particularly is really interesting to me, as I've mentioned, as a parent of neurodiversity. I'm really interested in them, creating a better diagnosis tool, for these different conditions, because, stress and atmosphere, environment is a factor in right now, when it shouldn't even be involved in creating the diagnosis. So I'm particularly interested in that, but I haven't heard anything more on that yet. But If somebody's out there and wants to tell us more about it, we welcome you to come on the show.
This is an open call for papers, I guess.
Right.
One of the interesting things was, it's funny because in 2025, and again, this is March, we're recording this on March 4th, right? Mardi Gras, as it were, Shrove Tuesday, if you prefer. This started the year with Jensen Huang basically trash talking the idea of quantum computer, or that would be decades out, and all the quantum stocks kind of crashed right away. And I think then cooler heads have kind of prevailed, and it's probably not a coincidence that all these innovations were started to come out of the lab, because I think his comments, although I don't think it was intended to, I wouldn't say like kind of crushed a lot of these hopes and dreams of a lot of quantum aficionados. But I also think it's probably not a coincidence that now all these companies are coming up with these things, right? Google kind of did it in December, right? Which ironically, their chip is called Willow, and my puppy that we ended up adopting was already named Willow. So I took that as a sign. So whenever I call her or yell at her for being bad, I think of Google's chip. But I think it's interesting because, you know, a lot of people kind of were like, well, wait a minute. Like, the only thing that can really disrupt, not the only thing, but one of the few things that can really disrupt NVIDIA's kind of market position is an advent of a practical quantum computer. Because a lot of these machine learning problems could be offloaded to that. A lot of the work there could be offloaded to a quantum chip. And a lot of people started putting their tinfoil hats on and thinking like, well, if he says that, he can buy up all these startups for pennies on the dollar, right? So I think there's a lot of backroom machinations going on. Candace, you meant collaboration in the good sense. I also think that collaboration in the bad sense is going on too.
I'm sure there's always bad actors out there,
right?
But when you think about like the major players of what's going on right now, right? We have some serious players, obviously, in the States: Google, IBM, Microsoft, Amazon, Intel. We've been talking about them. We haven't really talked a lot about what's going on in China, but China is obviously a serious player in this game. And I think that I could be wrong, but I think that China's focus is mostly going to be on trying to enhance their military and their defense. While maybe that might not be the primary objective, for example, in the States. In the States, they're, although maybe it is more now.
We don't talk about it as much, I think.
Right.
They do a lot more
DARPA
talking about such things. Yeah.
Yeah.
So this actually is, as of today, and according to Google News, 2 hours ago, the Zucon Hangzhou Changxi 3.0 chip launched, and it's a new quantum computing benchmark.
Wow.
So quantum advantage, superconducting systems, and it claims that it is 1 million times faster than Google's chip.
Wow.
Yeah. I mean, again, literally saw this as Candace was talking. So I can't really go into like, hey, what's this about? But It's also interesting to note that Amazon, I did some Googling with Bing, as we would say, and scrolled down. I don't work for Microsoft, so I don't have to say anymore. So they claim that the building error correction from the ground up using the cat qubit. This is a new type of qubit I heard. But it's also named after Schrodinger's cat thought experiment.
Interesting.
So
and applicable.
I'm still going to stand by the notion that it's a shout out to Minecraft.
Could be.
Maybe it's one of those happy coincidences. But it is interesting to see, like, the news here is happening at such a fast and furious pace. Like, it went from, nobody talked about quantum computing. Like, Eddie, when you and I originally had this, like we started the show because we were talking about quantum computing on the main show, datadriven.tv, and listeners are starting to get annoyed that we weren't talking about data or AI, right? So we're like, you know what? We can just start spin up another show, right? There's no overhead hardly to speak
That's
of.
fair. Now they have to come and listen to quantum computing to this podcast to become annoyed. It's an extra step, and we should apologize. Sorry.
I've been annoying people since I was born, so it's kind of part of my thing.
The reason that I went there, though, Frank, is every time I see quantum advances. Now, first and foremost, I recognize that the quantum advances don't just apply to one aspect of computing. I know that we're going to get to general purpose quantum, and it's going to replace or impact, get it, the other general purpose things that we have now, that we do now with large mainframes and clouds, clouds and cloud servers and arrays of the AI chips. It's going to impact that, and that's where I tend to focus. I kind of drift over to how's this going to impact data and then AI. So that's why that's just where my head is. And if that bothered people, I'll take this opportunity to apologize. It's just where my head's at. I've been doing data now for a long, long time. But I started out in just generalized computing. Let's see. You started
out with IoT when it was just the T.
That's true too. But when I got into, I was just thinking, it's in 2 months, in May, it will have been 50 years that I started playing around with stuff at the tender age of 11. And so I'm skewed. I know that. I didn't intend to bug people, but I do now focus more on data, and that means focusing on, LLMs, AI, and some machine learning. I'm kind of dabbling in that now, thanks to you, Frank. I hope you're proud of yourself, young man.
I am. I do have GPU envy because you have a really swanky GPU.
I don't think I do. I think it's
swankier than the one I have.
Really? Because it's like a 30 something. It's not a big one, but I was looking at the there's like a 5080 that just came out, and it's supposed to be breaking all the records. It's $2,000, whatever the $2,000 model is. It reminds me of when I would buy PCs in the late 80s. They were always $3,000. Didn't matter what the power was. All of the new ones were $3,000. You got to spend $2,000 on a GPU these days. That's just it. But you did. I finally caught up to you talking about that. I don't want to get too far off quantum, but talking about that other project named Fabric, not Microsoft Fabric.
Oh, okay, yeah. We should do a show on data driven on that. Yeah,
we should. Yeah. But anyway,
that's a cool product. I actually connected with the guy. So for those who are not familiar, Daniel Meissner has a product or open source project called Fabric, and it's basically, Candace, I showed this to you too. This is that thing, and you can it's a pattern of prompts that you can kind of pipe and feed into different workflows and stuff like that. Right now, it's the backbone of Dingo AI, which is kind of our internal be cool for quantum. Content management system. But I mean, I do have this machine from work, which is an M3. Nice. And the nice thing about Apple Silicon is that they have shared memory model with the GPU. So as long as I'm not using, it has 128 gigs. So I technically have 128 gig GPU minus whatever I'm running and I'm using. So like the shared model. I actually get the best performance out of any equipment on that machine. But like you, I keep wanting to go, and it reminds me of the olden days of computing, right? Like when, like you said, a new computer would cost $3,000 or $2,000. And it's kind of like, I almost bought a 4090 for my birthday, but then I see there's another 5090 because I knew I was afraid, as soon as I spend the $2,000 or $1,800, and I think Micro Center has a thing, the first purchase if you get a store credit card, you get 10% off. So I was kind of like working the math in my head. How can I make this work?
Okay.
And I was like, every time I'm like there, I'm looking at it, it's behind glass. I'm like, I want to, and I'm like, no, I'm not going to get it.
You're
Like,
like,
I'm just
That's
like,
right. That's it.
yeah, it's just like Ralphie in A Christmas Story, you know. But I think that, you know, and again, like, I don't think you're annoying people because like the shift of the show is not so much on the quantum physics part of it, although we will talk about that in certain episodes. But I think
Sure.
it really sparks the thing that really sparked the revival of the show was Candace's idea of the quantum curious, because I forget who I was talking to. It was like a year or two ago, but like, you know, quantum companies, quantum startups, all these things, they're going to need marketers. They're going to need recruiters. They're going to need salespeople, right? The salespeople are, I'm going to make a generalized statement here, but quantum people who study theoretical physics are probably not going to be the typical kind of Jordan Belfort type, Wolf of Wall Street type salespeople. I doubt I'm sure that in 8 billion people on the planet, there's probably one or two people, but that Venn diagram overlap is going to be very small.
Yeah.
Right. And, but you're going to need someone that can understand this. Like, how do you pitch what value does a quantum computer have to an enterprise? Right. Why do I care that this can do, the Willow chip, right? Like, why should I care that this can compute something in 90 seconds that where a normal computer would take multiple times the age of the universe, right?
Yeah.
Because at some point, if you think that and all of us here are technologists in this room, right, including you, Candace, right? if you talk to somebody about like the text and the specs, and you talk to a business decision maker, their eyes glaze over pretty quickly. Right. And that's just on basic kind of like, I set up an LLM, like I did this, and I have a fabric pipeline or whatever. And their eyes glaze over. But if you start talking about the age of the universe and photons, like you lost them, right?
That's crazy. Well, it's a big number.
It is a big number. It's far beyond what our human brains can fathom.
Yeah. And I imagine there are people out there who just think in those numbers all the time. I imagine astrophysicists. And,
God love them, though.
People,
we need people like that.
Yeah. We absolutely do. But for someone like me, it's just, I look at that and I can't fathom what that means other than it's just a large number. But, the size of a number that I can kind of get my head around is relatively small. I probably would win the golf score on that contest among we three. I'll just put it that way. My brain doesn't do super large numbers. And it's weird.
Just so I'm clear, lower numbers in golf are good.
Are better. Yeah, those are. I learned that the hard way. I thought I'd won, and I still think I win at golf every time I play. I get the most runs.
Well, good for you. It's the mindset. If you think you're the winner, you're a winner.
I love that.
One of my favorite movie clips, and it's from an old 80s movie, and it had Tom Hanks in it, and he was playing tennis. And he would spike the ball really hard and like get it over the fence, and he'd be like, home run. And then like I think the guy he was playing against was like, that's not baseball. Like
that is so funny. But you're right about all of the innovations, especially that have come out in maybe the last 3 weeks with the new state of matter Microsoft Research announced, and how that'll impact stuff. And it seems like we really did this leap, about a 3 orders of magnitude leap, if I'm doing that math right, from
a quantum
where we were
leap,
playing. I dig it. From thousands, 1,000 or thousands of qubits into the potential for millions. So it'll be interesting to see.
And
what happens if you go ahead?
No, go ahead.
What happens if you put all that together? If you fix error correction, if you've got one platform that seems to be focused on that, and you've got another platform that, seems to manage the volume of qubits that you can put out, and another that increases the stability, of those, maybe even the speed of reading the state, in quantum flux. What happens when you put all that together, just from the pure hardware standpoint, and that's probably some next step, where people start kind of combining all of these innovations and adding them, making them additive. So I'm excited about, what where the hardware is going to go, and a little worried as well. Right away, somebody talked about encryption, and I'm like,
that always comes up.
Well,
And my prediction is that, and this has already happened with some of the prep calls we've done where we talk about encryption and quantum role in it, and they kind of like, yeah, I don't want to talk about that. Like, so like in the sense that in data driven, people got annoyed that we were talking about quantum. I suspect that there's going to be there could be a third show or third kind of thing where we just talk about the security aspects of this, right? Because
it's kind of cute, right? When you think about it, because I'm like, you're only looking at one half of the equation here, and you're looking at, standard encryption today, being 256, whatever, 1024-bit encryption, whatever it is, being able to crack that in less than a second with a quantum computer. Okay. But if you think about the other side of that is, right now we generate encryption with those amount of bits, and we're able to do that in a handful of seconds as well. Why doesn't it stand to reason that we'll come up with, I don't know, 1 million bit encryption that quantum can generate for us, in a couple of seconds, that will then stymie the ability of someone to use a quantum computer to crack that?
No, I think you're right. And encryption is one of those things that's a fascinating field because it's something you don't think about. And I'd love to do a deep dive show on this, right? Because it starts off, at one point, I remember, I can't think of the guy's name. Shame on me for not thinking of the guy's name, who was behind PGP.
I know who you're talking about.
You know what I'm talking about.
He did some contracting for one of the 3-letter agencies.
I don't know if he did, because at one point he was a pariah amongst the 3-letter agencies.
Well, I think he was a contractor at a minimum.
He might have been.
One of them in particular, the acronym was classified. It may be. But even the acronym of one of them was classified for decades.
Right. And that's just it. When you get into encryption, like you get into these, like, no one really knows publicly what the real state of the art is. And it's a fascinating little corner of the world, mathematically and computationally. And I just remember this because I remember reading about the early days of PGP in Wired magazine, back when we would print things on paper. Kids.
That's crazy.
And it was, he basically, apparently he had a history of being like an anti-war protester, but he had to register as an arms dealer because encryption technology, it might still be the case, but in the 90s was classified as military tech. Right. And which makes sense, right? Because historically, they were talking about the Caesar cipher, right? And going back throughout time, like it was an important military secret. But like now it's just the backbone of commerce, right? Every time you put your credit card into Amazon or whatever, it's secured by encryption, which was probably during the era of previous world wars would have been considered military grade or above military grade, right? And a lot of the genesis of computer science, or the money that went into it, right? The two big drivers in the 20th century was World War II, breaking encryption, right? Alan Turing and all that, and then the space program, right? Because it was, if you had a research facility, it's fine if the computer takes up the entire basement, right? Or several buildings. But if you wanted to get that thing into orbit or on the moon, you'd have to shrink it down. So those are the two major drivers. And I think, it'll be interesting to see what the major drivers of the 21st century are going to be. Obviously the web is going to be one of them.
Yeah, or even the rest of this decade, the way things are going.
Yeah.
But I'll stop talking about encryption after this. It's really, if I understand it, I'm going to really, really oversimplify it. So if you're an encryption guru and this irritates you, apologies in advance.
And come on the show and tell us that we're wrong.
Yeah. Tell me I'm wrong. It's about managing very big numbers, especially very big prime numbers. And I'm not saying all I'm seeing this do in the sense that, it's petty. That's not what I mean at all. But if I take one step back and thinking, orders of magnitude again, I'm just looking at increasing the size of the prime numbers, being able to grab those very, very quickly with new hardware and a new opportunity to then do what you do with encryption. And it's probably going to facilitate even more approaches to dealing with encryption. And again, I think honestly, what will happen is similar to what happened to older encryption when we started doing PGP and the like. Those older encryption methods were easier to crack, and with what we now call standard or commodity hardware, I think the new hardware will facilitate new and better and equally hard to crack algorithms. So now I'm done. I'll stop.
I think there's a lot to talk about here, and again,
Agreed.
I think we're really at that transistor moment where suddenly this is going to become a big thing. And if you look at, Microsoft made some bold claims, and I've been in some discussions about, well, theoretically it could support millions of qubits, but if you read the press release very carefully,
Sure.
They didn't say that they made it millions of qubits, right? They just said theoretically.
Yeah, they haven't built it yet. Yeah.
But I think the discovery or creation of a new state of matter, I think, is worth, to me, that's like, wait, what? Because when I was a kid, there were only 3 states of matter. Right? Now there's 4 officially recognized, plus now possibly a 5th one, plasma being the new entry. And it's very sophomoric, but like Ali G has a whole thing where he talked to a chemist and he was talking about the 3 states of matter. It's totally rude and gross, but it's Ali G. I don't know why I got on that sidetrack. I'm sorry.
Because now we need to make a new one to show the new states of matter.
That's right. Go. We need to bring Ali G out of retirement.
Right.
So, I'm pretty sure Sacha Baron Cohen does not listen to us, but hey, someone who knows him might.
Right.
But anyway, I just think that it's interesting how this year started with quantum, where it started off as kind of like, oh no, Jensen trash talked the technology. And now you're seeing these announcements come out fast and feverishly.
No, it's true. It shows the global interest, and how people get excited about innovation and what is the next step, and understanding that we don't know how long it's going to take, but we do know that we can start learning about it, educating ourselves, and figuring out where we would like to see it go. Because, we as consumers and some of us business owners, we have a stake in it and understanding it, because it's going to change everything that we understand right now. So we're going to have to learn how to work with it and help it master whatever is the next step that we want to figure out.
Very true.
Yeah, and I think that's where the real opportunity is. The real opportunity is in the things, the unintended consequences we can't imagine, right? Who would think that a bunch of people working in a basement somewhere in the outskirts of London, you're trying to crack the Enigma machine, would lead to smartphones and Uber, right? Like, who would lead to the internet? The internet would lead to smartphones, social media, and all of that, and an entire industry now that exists, right? Both good and bad, right? Like cybersecurity, cyber warfare, like that is very real. Mm-hmm. And that is the, we can't ignore that. And maybe it's the pessimist in me. Maybe it's the fact I live in the DC area. Like, warfare tends to be a driver of technology, since the Chariot, to breaking encryption and things like that. And I think our next guest is actually going to be the CTO and founder of a post-quantum encryption company, which actually doesn't work with, well, I'm sure it works with very large numbers, but the math is different. It's not about factoring primes anymore.
Interesting.
So it'll be interesting to see how does that evolve? Like, what does that look like? What does a post-quantum encryption industry look like? And all sorts of stuff. We had a pre-call with him, and I was like blown away by like, oh my God, I didn't think of that. Oh my God, I didn't think about that. And that's when you know when you're in exciting times or an industry. It's like, oh my God, I didn't think about that. I like to call it the Circle K problem, right? Like, when people were building gas stations in the 40s and 50s or whatever, you didn't think about the convenience store aspect of it, right? You don't think about and apparently one of the things that happens, at least in the U.S., obviously the U.S. is a very car-centric culture. Canada is probably a bit like that too. But totally lost my train of thought. Oh, but when gas prices go up, all those convenience stores that are attached to gas stations, they actually make more money selling you chips and candy and big gulps and slushies than they do on the gasoline.
I did not know that.
Yeah, I forget what the number is, but it's one of the things that when gas prices go up, immediately the businesses that get hurt are the convenience stores attached to that, because if you're spending X amount more filling up your tank, you're not going to feel so generous, or you may not have it, right? Like, you're not going to go in there and have the sketchy looking hot dog or taco that's on the little rolling machine. But the money they make per gallon is very low, actually, which partly explains why so many gas stations have convenience stores attached. It's not just for the convenience, it's for the money as well.
Okay.
There we go.
Awesome.
So what do y'all think is next? Y'all are the Impact Quantum hosts. What do you think is the next thing? Do you think it's going to be more qubits? Do you think it's going to be
I think there's going to be
correction?
I think it has to be error correction.
Yeah.
You can add qubits up the wazoo, right?
Yeah.
But until you fix the error correction problem,
you're stuck, because the more we learn about the errors, and it's just it's so much more of a problem exponentially than any other type of error situation, that, because of the entanglement issue. And once the qubits are entangled and then there's an error, and it just does, you can't just kind of go in and fix it. It affects everything. So until they really can work better to manage that, you can't continue to increase qubits and qubits capability until you can solve something simple like that.
Well, you can, but it won't do you any good. Yeah.
Right. Exactly.
But you kind of said that like midway through the thing. I was like, but you're right. Like, I mean, let's just say Microsoft does on the Majorana chip, like how I did that.
Yeah, I did.
Even if they get it to 1 million qubits, if there's no error correction, right,
what does it mean?
It's an academic exercise, right? And I think that might be the genesis, the seed for kind of Jensen Huang's comment at CES was it's going to be X number of years before a quantum computer will be practical. And I think error correction is going to be a key component to that being practical. Now, there are probably a bunch of other like day 2 operations we haven't thought of yet, but
the thermal issues that have not been addressed at all.
Right.
So, and that's major. Really. And until they can kind of address that legitimately, does it really matter? This one is 1 million times faster, is 1 million times more qubits. It doesn't matter if you can't handle or address the thermal issue, if you can't address the error correction. Those are 2 kind of barriers, for sure.
That's a good way to put it. And with that, we'll let Bailey finish the show.
And that's a wrap on this episode of Impact Quantum. From AWS's Ocelot chip to the never-ending battle of error correction, we've covered the highs, the lows, and the we'll see where this goes of quantum computing. As always, the quantum landscape is evolving faster than you can say superposition. So stay tuned for more breakthroughs, bold claims, and possibly even a few reality checks. Want to stay ahead of the quantum curve? Join our mailing list for the latest updates, insights, and exclusive content. Just head over to impactquantum.com and click join. If you've got thoughts, questions, or a burning desire to tell us we're wrong, we welcome it. Reach out. And if you enjoyed the show, give us a like, a share, or better yet, send a quantum signal into the void. Until next time, keep questioning, keep learning. And remember, in quantum computing, uncertainty isn't a bug, it's a feature.